Hi, George Diamond here again. We are looking, today we're going to look at finding the antiderivatives of some exponential functions. So this is the second video in section 5.4 of our textbook. Now the first video we focus on derivatives of exponential functions, of the natural exponential function. So we've already looked at differentiation. This is part two. So we're doing this as two separate videos. Because if you don't, it gets to be kind of long, very long video. So we kind of break this up into two videos, into two parts, kind of. So this is part two, if you will. So as we get started, first we looked at several integrals of some of our trig functions. There's several of them on one of my previous videos. We did several of the trig functions that we hadn't done before. But I think so far we need to make sure we know all 6 trig functions. Alright, so all 6. Like I said, 2 or 3 of these we did in one of my videos. But here's our first. Right, now, if you're taking AP Calculus, if you're an AP Calculus student, you need to have these memorized. And I'd say even if you're just a college student or whatever, chances are, on an exam or something, your teacher's not going to allow you to have a reference sheet or something like that. Where you'll be able to refer to these. So this is one of these things that you really have to have memorized. All right. So when you come across these, there's nothing to look them up. If you're taking the AP Calculus exam, there's no reference sheet that you can use. These you have to have memorized. So the first one, the antiderivative of sine u is negative cosine u plus c. You got to have that memorized. Antiderivative of sine is negative cosine plus c. The antiderivative of cosine u is sine u plus c. Alright, so the antiderivative of cosine is sine. The derivative of sine is cosine. So the antiderivative of cosine is sine u plus c. Now the antiderivative of tangent u du. Now this is one that we did this on one of my videos. You have to rewrite this as sine over cosine, and then it comes out as a logarithm, right? So really we could not introduce the antiderivative of tangent u until we knew how to integrate a natural log. Right? So the antiderivative of tangent u du is negative natural log cosine absolute value cosine u plus c. Right? So these last 4 involve natural logs. Right? Now the number 4 here, the antiderivative of cotangent u du is natural log sine u plus c. That is absolute value sine u plus c. Number 5, the antiderivative of secant u du is natural log absolute value. Now this is kind of hard to memorize, right? But you got to remember the antiderivative of secant u du is natural log secant u plus tangent u absolute value of that quantity plus c. So that you need to remember. The antiderivative of cosecant u du is negative natural log absolute value of cosecant u plus cotangent u plus c. Now, kind of an easy way that I always kind of memorize these. I remember, I can remember. It's been a long time ago since I took a calculus class, but I can remember in college when I took my first calculus class trying to memorize this stuff. The antiderivative of secant, I knew it was a natural log of something plus something. So when you think about it, it's secant is natural log secant plus tangent. Right, so secant plus tangent. The cosecant now is negative, once again, cosecant plus cotangent. Right, so it's kind of made it a little bit easier to have memorized. So secant, antiderivative secant is natural log secant tangent u. And the antiderivative of cosecant du is negative natural log cosecant u plus cotangent u. Right, so my students, we need to have these memorized along with the derivatives of the 6 trig functions. So when I teach AP Calculus, when my students take the AP Calculus exam, there's no reference sheet that you're going to have with you. Those you simply have to have memorized. All right, so let's go and get to today's item. Today we're looking at derivatives of integration or integrals of exponential functions. Now here's the rule. The derivative of e to the x is e to the x. So the antiderivative of e to the x dx is e to the x plus c. So remember, e to the x is its own derivative. So when you integrate e to the x, you get e to the x again. So the derivative of the x is e to the x, so the antiderivative of e to the x is e to the x plus c. And the antiderivative of e to the u, du, is e to the u plus c. Now, needless to say, most integrals involving e, right, so exponential functions, we're going to have to use u substitution a lot. Yeah, but first, let me, looks like somebody left a softball laying around. My roommate is one of my students. I got several students that play softball. Let me get this out of the way, and we'll be ready to get started. So let me get that over. All right. So we've got several examples we're going to run through, and so we'll be using a lot of u substitution with integration. So that's just how it goes. So let's try a couple examples. All right, let me get this erased here. Okay, there we go. So let's see if we can find the indefinite integrals. So find the indefinite integral. So a couple examples. Right, so here's our first. So we'll start off with an easy one. Now the easiest antiderivative involving e would be, antiderivative of e to the x dx is equal to e to the x plus c. That's the easiest. Everything else, we're pretty much going to have to use u substitution with. So, but that's the easiest. So I just wanted to throw that out. So the example that I want to do here, first, let's do e to the 5x plus 1. So the antiderivative of e to the 5x plus 1 dx. All right. Now remember, e to the 5x plus 1, we need to get e to the u. That means the u substitution. So to start off, these all, there's really no question hardly, usually as to what you're going to let u be equal to. U is pretty much going to be equal to your exponent. So we got to get e to the u, not e to the 5x plus 1. All right, so as we set this up, we're going to do u equals 5x plus 1. Du then is going to equal, the derivative of 5x is 5. The derivative of 1 is 0, so it'll be 5 dx on the right-hand side of our equal sign. Now remember, with u substitution, I like to always solve for dx. And then we're just replacing the dx with a du dx expression. So dividing both sides by 5, that gives us 1/5 du equals dx. So substituting in, it's become e to the u times 1/5. So 1/5 du. Now we can pull the 1/5 out front, so it becomes 1/5. So 1/5 integral e to the u du. All right, so there we go. So we should see that e to the u. Now the antiderivative of e to the u is itself. Right, so as we integrate here, it becomes 1/5 e to the u plus c. So that is our antiderivative in terms of u. Now we need to convert back into terms of x. So let's go ahead and take the 5x plus 1, substitute it back into our answer here. It gives us 1/5 e to the 5x plus 1 plus our constant of integration. And that's our indefinite integral. So 1/5 e to the 5x plus 1 plus c. Okay, let's try another example. And we're going to run through. We'll look at about 9 examples today. So most of these should go pretty quickly. So here, let's take a look at another one. So number 2. Right, so number 2, let me erase this over here too. Right, so our second example, let's try the antiderivative of 7x, say e to the negative 2x. So e to the negative, so let's see, the negative x squared. Let's see, we'll try this dx. So let's try this antiderivative here. Let's see what we get. So this integral. So start off, we want e to the u, not e to the negative x squared. So let's let u equal negative x squared. So du is going to equal negative 2x dx. So we'll take your derivative. The derivative of negative x squared is negative 2x. Divide both sides by negative 2 gives us 1 over negative 2x du equals dx. All right. Now let's go ahead and make our substitution. We have the integral 7x e to the u now times 1 over negative 2x du. Okay. Now notice the x's cancel out. So all the x's are gone. So I want my integral completely in terms of u, no x's left. If you got an extra x left over you can't get rid of, then sometimes you can go back to the original substitution and you can eliminate that other x. So here we got 7 over negative 2. We'll pull this out front as negative 7/2 integral e to the u du. So this is where I want to be. I need to see that e to the u. So our antiderivative now is negative 7/2 e to the u plus c, okay, which is equal to negative 7/2 e to the negative x squared plus c. So last thing you want to do, take that negative x squared, substitute it back in for u from the original substitution. So remember to write your answer back in terms of x. So convert from the integral, your answer here in terms of u to in terms of x. All right, let's try another example. And we're just going to run through several of these. A pretty easy one. Okay, let's try. And I'll erase the directions here. We got the idea. Okay, let's try this one here. We'll try the antiderivative. So this will be number 3 of e to the 1 over x squared. That's it. Dx. So e to the 1 over x squared. Let me double check and make sure I got it copied down correctly. This is it. All right. Now, the problem is e to the 1 over x. So we're going to start off, let's let u equal 1 over x. So we don't want e to the 1 over x. We need e to the u. All right, so that we can integrate. Now first of all, 1 over x is the same thing as x to the negative 1. So I want to rewrite that. Let's do that little fraction. So I'm taking the derivative now. This will be du equals. Now the derivative of x to the negative 1, remember, is negative 1x to the negative 2 dx. So bring the negative 1 down front. So remember to subtract 1 from your exponent, makes that x to the negative 2 now. So now du is going to be equal to, and I want to rewrite this as negative 1 over x squared dx. And solving this for dx, we're going to multiply this side by negative x squared. Right, so these will cancel, multiply here by negative x squared so here we end up with negative x squared du, okay, equals dx. So you want to isolate the dx, so solve this completely in terms of dx. Okay, now let's go and substitute back in now. So we have the antiderivative, e to the u over x squared times negative x squared du. All right, now you can see the x squares are going to cancel, so these cancel out. We'll pull the negative out front, so it becomes negative integral e to the u du. All right. Now we've written our integral completely in terms of u. We're ready to find our antiderivative now. This will be negative e to the u plus c. Substituting back in now gives us negative e to the 1 over x plus c. And that's our answer. So we're done. Okay, let's try another one. And so we're just kind of going pretty quickly through these. Let's try a trig example. All right, so one involving trigonometry. Let's try a problem like that. Let's try number 4. Let's try a trig problem. All right, erase this. And let's see, this time number 4, let's try, this will be the integral sine x e to the cosine x dx. Okay, let's try this problem here. Now, once again, we don't want e to the cosine x, we need e to the u. So we're going to let u equal cosine x. So whatever the exponent on your e part, your e factor is, you're going to let that equal u. All right? So we're going to let that equal u. So to start off, let's let du, taking the derivative of both sides. The derivative of cosine, remember, is negative sine, so it'll be negative sine x dx. So the derivative of cosine is negative sine. Dividing both sides by negative cosine, so we have 1 over negative, or divide both sides by negative sine. So it'll be negative sine x du equals dx. So let's go substitute back in. So our integral becomes sine x e to the u times 1 over negative sine x du. All right. Now the sine x's are going to cancel out. Now we still have this negative here, so once again we'll pull the negative out front and make these as e to the u du. All right. Okay, that wasn't so bad. Pretty quickly we're able to convert from the integral in terms of x into one completely in terms of u now. So finding the antiderivative, so negative e to the u plus our constant integration, so negative e to the cosine x plus c. This is our antiderivative now. so that wasn't too bad. That was a little trig problem. Let's try a fraction now. So let's try a fraction. Let's try some fraction. Okay, so let's see. This would be our fifth example. All right, so this will be the integral. We got e to the x minus e to the negative x over e to the x plus e to the negative x dx. So let's try this one right here. All right. Now, how do we find the antiderivative of a fraction? Well, we use what? The quotient rule for integrals. Except we don't have a quotient rule for integrals. We've got a quotient rule for derivatives, but we don't have a quotient rule for integrals. If you have a fraction, look for a natural log relationship. Okay, do you have u prime over u? Is the top of that fraction the derivative of the denominator? Let's check this fraction here. Look at the denominator now. The derivative of e to the x, e to the x. There you go. The derivative of negative e to the x is negative e to the negative x. There you go. We have a natural log relationship. Now remember, when you integrate this will give us natural log absolute value u. So this right here is what we're seeing in this integral now. So we'll start off and let u equal the bottom of the fraction here. So u equal e to the x plus e to the negative x. Now, if you can see that, if you can see the answer right now, you can actually skip this step, right? Because I can pretty much tell what our answer is going to be here. Now, finding the derivative though, du is going to equal the derivative of e to the x is e to the x. The derivative of e to the negative x, if you remember this from our last video, is negative e to the negative x dx. Now, dividing both sides gives us 1 over e to the x minus e to the negative x du. That's equal to dx. Now let's make our substitution. So our integral e to the x minus e to the negative x over u times 1 over e to the x minus e to the negative x du. Now you can see the top of your fraction is going to cancel out completely with the bottom of the fraction, so there's no x's left now. So what we have 1 over u du. Now that's a natural log, right? So that's a natural log. So this will be natural log absolute value u plus our constant of integration. Now you got to watch out. If it's a fraction, remember we do not have a quotient rule for integrals, only for derivatives. So if you have a fraction like this, you've got to watch out. Is the numerator the derivative of the denominator, or can you make it? So you're going to have to use u substitution here to get possibly a natural log relationship. So let's put this back in terms of x. So this will be our answer here. Natural log absolute value e to the x plus e to the negative x plus our constant integration. So that's going to be our final answer. So watch out for fractions. There is no quotient rule. All right, so let's try this right here. So erase this. Erase this. Let's try another fraction here. Let's try number 6, another fraction. Let's try the integral e to the 2x. Let's e to the 2x plus 2 e to the x minus 1. Actually plus 1. Divided by e to the x dx. Now you notice on my video here that some of these problems, or a lot of them, you can find in our textbook. We use the Larson text, so I pick out some of the homework problems. Some of the even problems, you didn't kind of go through them here on the video. I may pick out some problems where the explanation in the textbook, but you'll see these in the Larson text too. So you can kind of refer to those. There are a lot of them with you. Right? Now, once again, I said you got a fraction, watch out for a natural log relationship. But now, you look at this here, you've got what would be like a trinomial almost. So you got 3 terms, right? And like a monomial factor in the bottom of the fraction. You don't have a natural log relationship here. So automatically, when you see a single term on the bottom of your fraction, we need to divide that into each one of those terms in your numerator. So we're going to divide this, break this up into three little fractions. We're going to do e to the 2x divided by e to the x plus 2e to the x divided by e to the x plus 1 over e to the x. dx. Now, let's simplify this now. So this becomes the integral. Now, whenever you divide e to the 2x divided by e to the x, so remember, I'll do this over here, e to the 2x divided by e to the x. Now remember, whenever you divide factors with the same base, you subtract your exponents. This becomes e to the 2x minus x, or just e to the 1x. So this division is going to be e to the x plus. Here the e to the x's cancel out, gives 2 plus. And let's see, this becomes e to the negative x. 1 over e to the x will be e to the negative x dx. Now, you kind of think of this, I only want to integrate each of these terms. All right? If you want to, you can actually break it up into 3 separate integrals. All right? So this will be the integral e to the x dx plus the integral 2 dx plus the integral e to the negative x dx. So you can actually break it up into three different integrals. Okay, or you can just skip this step and find the antiderivative the way it sits. So the antiderivative of e to the x is e to the x plus the antiderivative of 2 is 2x plus. Now the antiderivative of e to the negative x is negative e to the negative x plus our constant of integration, that's it. So the antiderivative, like I said, you can just leave this step out completely, right? The antiderivative of e to the x, antiderivative 2, 2x, and the antiderivative of e to the negative x is negative e to the negative x. So you can just skip that step, find the antiderivative of each term, and you've got it. All right, let's take a look at it. Now once again, just remember, let me just review, make sure if you have like it's not really a monomial, but if you have like a monomial term in the bottom of a fraction like this, any kind of fraction, typically you're going to divide each of those terms in your numerator by that term on the denominator. All right, so you got to divide it, simplify it, and then integrate. Okay, that's number 6. Let's try number 7. Okay, let's try a couple of indefinite integrals. The area under a curve. So this is the fundamental theorem of calculus. So let's do a couple of indefinite integrals. All right, so let me erase this. We'll do a couple of these. Do a couple of indefinite integrals, and I want to finish up with a differential equation. How's that? So let's try. So let's see if we can evaluate each. So evaluate. Okay, each definite integral. Now we're finding the area between the curve and the x-axis on each of these. So let's do our first problem. Okay, let's do the integral from 0 to 1. So our upper bound and our lower bound. E to the x over 1 plus e to the x dx. Okay. So let's see. Now to integrate this, now one thing I noticed now as I look at this, is anytime you've got a fraction and we don't have a quotient rule, do we have a natural log relationship here? So is the numerator the derivative of the denominator? And if you notice, the derivative of 1 is 0. The derivative of e to the x is e to the x. So I see that e to the x in the numerator. That's a natural log. So we're going to get a natural log here. But let's start off and let u equal 1 plus e to the x. So du, the derivative of 1 is 0. The derivative of e to the x is e to the x dx. So divide both sides by e to the x, being 1 over e to the x du equals dx. Now, with a definite integral, I'm going to go ahead and change the upper and lower bounds also. Because remember, the upper and lower bounds, this is x equals 0, and this is x equals 1. So we want to convert from terms of x to in terms of u. So completely in terms of x and in terms of u. So let's substitute u of 1. So we'll go back up to the original substitution here. This will be 1 plus e to the first power, which is 1 plus e. So the upper bound becomes 1 plus e. The lower bound will be u to the, this is 0, so it'll be u 0, and this will be 1 plus e to the 0 power. Now, of course, anything to the 0 power is 1, so you have 1 plus 1, which is 2. So the lower bound is 2. Okay, then we set this up, will be e to the x over u times, let's substitute over here, it'll be 1 over e to the x du. And the e to the x's cancel out. And we end up with the integral 1 plus e over 2, 1 over u du. Now, we got to be careful here. A lot of times when we a lot of times when we change the upper and lower bounds, the lower limit will be smaller than the upper limit. So do I need to switch the upper and lower limits here? Do I need to move the 2 up here and the 1 plus e to the bottom? Now remember, e is approximately 2.7, so it's about 2.7. So if you got 1 plus 2.7 is going to be about 3.7, so 1 plus e is going to be bigger than 2. We don't have to switch those. All right, so 1 plus 2.7 is about 3.7. So 1 plus e is about 3.7, so we don't have to worry about switching the upper and lower bounds, but you do have to be careful there. Okay. All right. Okay, let's find our antiderivative here. Erase this here too. Let's get our antiderivative. The antiderivative, 1 over u, that's a natural log. So I'm going to do natural log, absolute value u, from 2 to 1 plus e. So from 2 to 1 plus e. Now, substitute the upper bound first. This will be natural log, absolute value 1 plus e, and absolute value. I'll put this in grouping symbols, minus. Substitute the lower bound now. This will be natural log, absolute value 2. Okay. Now, I got the absolute values in here, but you notice now 1 plus e is like 1 plus 2.7. It's going to be positive, so I can drop the absolute value here. This is natural log 1 plus e minus. Also, natural log 2, we can drop the absolute value there too. It'd be natural log 2. All right, now if this were a problem on, if you're taking the AP Calculus exam, for example, if this is a non-calculator problem, that's the way your answer would look. Or it may look like this. It could be natural log 1 plus e over 2. So you could be in combined form. So just kind of watch out. So be able to write your answer. You should be able to do this problem without a calculator. Now, if you got a calculator, you can punch it up. Now, when I kind of approximated this, you get about 0.620. So I punch it up on my calculator. You can kind of check and see if you got the same answer that I got there. Okay, let's try. We have 2 more problems. Let's try another definite integral. Let's erase this. So let's try another definite integral. All right. Okay, and this time let's try a definite integral. So we're talking about trigonometry. This will be number 8. So try the integral from -1 to 0. So -1s are lower bound, 0s are upper bound. Now remember, we're finding the area between the curve and the x-axis now from -1 to 0 on this curve. And this will be e to the x cosine e to the x dx. Make sure I got it copied down correctly, and we do. All right. Now, to start off, where do I want? I can see e to the x's here. I've got 2 e to the x's. So I'm going to let u equal the e to the x inside the cosine function there. So that's a composite function. So let's let u equal this e to the x here in the cosine. So du is going to equal e to the x dx. So remember, the derivative of e to the x is itself. Right? And solving for dx gives us 1 over e to the x du equals dx. Okay. Now, let's also go into the upper and lower bounds too. So we'll do the upper bounds. So this will become the integral. So what is our upper bound? So the e sub 0 will be e to the 0 power, which is 1. Yeah, so this becomes 1. Okay, let's do the lower bound too. So u sub -1 would be e to the -1, which is 1 over e. All right. Okay, so the lower bound becomes 1 over e. Now, gotta think about this now. Do I need to flip those? Is 1 greater than 1 over e? So think about this now. 1 over e is approximately, let's see, 1 over e. So 1 over e is approximately 1 over 2.7, which would be about, it'd be less than 1/2, so it'd be about 0.4. So 1 over e is about 0.4. 1 is bigger, so we don't have to worry about flipping the upper and lower bounds there. But you do have to be careful, because sometimes whenever you convert from terms of x to terms of u, you do have to switch those. But we're good here. All right. So we we set up our problem here, this will be e to the x cosine u times 1 over e to the x du. Right? The e to the x's cancel out. And this will leave us with 1 over e cosine u du. Right. And so I believe we're ready to get our antiderivative, so I'm going to erase this over here. Now the antiderivative of cosine is sine, right? So this would be sine u from 1 over e to 1. Okay. Now that's our antiderivative. Substitute the upper bound minus the lower bound. This is the fundamental theorem of calculus. This becomes sine 1 minus sine of 1 over e. Okay. Now, once again, if you're taking the AP Calculus exam, and this would be a non-calculator problem, this is the way the answer will look. Sine 1 minus sine 1 over e. Now, if it's a calculator problem, you would get 0.482 approximately. So 0.482. If you have a calculator that has e on it, you can kind of check that. I think it's right, but you never know. Okay, let's try one more problem. Okay, let's try a differential equation. That would be a good one to end on. Let's try a differential equation. Okay, we can do the definite integrals. So let me erase this. All right, there we go. And let's try a differential equation. Equation. Alright, so let's see, this would be number 9, I think, if I'm keeping count correctly. Okay, let's try this equation right here. So dy over dx is equal to, now we're going to do a particular solution, all right, at a particular point. So this would be x e to the negative 2x squared at the point, now we'll do at the point 0, negative 3 halves. So at point 0, negative 3 halves. I'll put my point up there. All right. Okay, let's see if we can solve this differential equation now. All right, so that means when we're finding a particular solution, remember we're looking for the one curve that will pass through this point. So that's a point on the original curve. So we're going to write an equation for the graph passing through this point right here. Now, we're going to start off on multiply dx to both sides. We have dy equals x e to the negative 2x squared dx. And we're going to integrate left and right. Now the antiderivative of dy, you're actually integrating 1 dy with respect to y gives us just y. So we have y equals, and now we're going to have to integrate the right-hand side. Now to find the antiderivative of x e to the negative 2x squared, we have to use, you guessed it, u substitution. So let's let u equal negative 2x squared. All right. Now let's take the derivative of both sides. So du equals negative 4x dx. Right. Dividing both sides by negative 4x, we have 1 over negative 4x du equals dx. So let's substitute back in over here. This will give us our integral x e to the u times negative 1 over 4x du. And you can see the x's both cancel out. And that leaves us with negative 1/4. Let's pull the negative 1/4 out. So we have y equals negative 1/4 integral e to the u du. Right? And that's where we want to be. Now the antiderivative of e to the u is itself. So we have y equals negative 1/4 e to the u plus our constant of integration. All right. So that's going to be. Now, when you look at this answer here is our general solution, right? So that's our general solution. We still need to get our particular solutions. That means we gotta find C. We gotta find C. Try that again. So let's see if we can find C. Now, so substituting in for x and y. Now we have negative 3 over 2 equals. So substitute the negative 3 halves in for y. That's going to equal. This over just a little bit. Yeah, so negative 3 over 2, that's going to equal negative 1/4 e to substitute 0 in for x. See, I need to go ahead and convert this back in terms of x, don't we? So this should be y equals, I didn't do that, negative 1/4 e to the 2x, let's see, 2x squared was it? Negative 2x squared. So negative 2x squared plus c. So you want to go ahead and write it back in terms of x. Okay, so now we substituting 0 in for x gives e to the negative 2 times 0 squared plus our constant of integration. Right. Now we're going to solve this equation for c. So we end up here with negative 3/2 on the left equals, so it'll be negative 1/4 e to the 0 power plus c. Now remember, e to the 0 power is 1. All right, so here we have negative 3/2 equals negative 1/4 plus c. So it'll be negative 3 over 2 plus 1/4 equals c. And let's see, we're going to have to get the same denominators here. So this will be negative 3 over 2. Negative, so at least how long before, so it'll be negative 6/4 plus 1/4 equals c. And it'll be negative 5/4 equals c. So our constant of integration is negative 5/4. So as we write our particular solution now, will be y equals negative 1/4 e to the negative 2x squared minus 5/4. And we are done. So that's the end of my video. So this is wanted to finish up with a differential equation. Now my classes eventually will be doing a kind of a unit on differential equations later, but that'll be actually fairly soon. But our answer, y equals negative 1/4 e to the negative 2x squared minus 5/4. So you got to use your point, substitute it for x and y, solve for c. So hopefully we now know how to integrate e functions. So just a lot of u substitution. So we are ready now. Let's go do our homework.